Hi all, here's just a quick video running us through the different angle properties that we can have. Firstly, we can talk about angles on a straight line, and we know that angles on a straight line, if I draw an angle in here, angles on a straight line add up to 180 degrees. So say this is angle A and this is angle B. A degrees, whatever A would be, and A represents a number, A degrees plus B degrees equals 180 degrees. And they have a special name. They're called supplementary angles. Then if we've got an angle that is worth 90 degrees, that's a right angle. So it looks like that, it's that size, and we often indicate it by that square box. So that's a right angle and that's equal to 90 degrees. And if we have two angles which make up that angle, so we've got an angle cutting through it like these, two angles which add up to 90 degrees, so again that would be angle A and that would be angle B, but this time A plus B equals 90 degrees. They're called complementary angles. So we've got supplementary angles which add up to 180, complementary angles add up to 90. Now there's a whole lot of angle theorems to do with parallel lines. So parallel lines, remember, they're lines with exactly the same slope. They look like train tracks. They're never going to meet each other because they have the same slopes. They travel next to each other forever. So they're parallel lines. And if we get a pair of parallel lines like this one here and we cut it through by a line called a transversal, so that line is called a transversal, what that gives us is a whole lot of angles for a transversal, and that gives us a whole lot of angles, and there's a whole lot of angle properties that we can talk about when we've got that situation. So we're just going to start with talking about something called alternate angles. So alternate angles look like this. They're when you've got that pair of parallel lines, but as you can see here, you've got angles marked on the inside of those parallel lines. So we've got this angle marked here, and we've got this angle marked here. Now what you'll notice is that those two angles that we've marked there are angles on opposite sides of the transversal, and they're within the parallel line. And they're called alternate angles when they're on opposite sides and within the parallel lines. So that's our first angle theorem, alternate angles which are on opposite sides of the transversal and actually within the parallel lines. They're not on top or below of those parallel lines. Then we have this example down here, and these are known as corresponding angles. So they're called corresponding angles because they're in the same position relative to each other on the parallel lines. So as you'll notice, this one here is on top of the parallel line, and this one's also on top of the parallel line, and they're on the same side of the parallel line of the transversal. So they're on the same side of the parallel lines and also on the same side of the transversal. So these ones are both on top and both on the right hand side. These are both on the bottom and both on the right hand side as well. You could do the same thing if you put them both on the left hand side, but they're corresponding angles. They're in exactly the same position and they are also equal. So that's corresponding angles, also equal. So alternate angles are equal. They're the opposite sides of the transversal and within the parallel lines. Then we've got corresponding angles which are also equal. They're on the same side of the transversal and of the parallel lines. And finally we have something called co-interior angles. And that's what we've got up here. So they're not equal to each other. They add up to 180 degrees. So they're within the parallel lines and on the same side. So alternate angles were within the parallel lines but on opposite sides of the parallel lines down here, but on opposite sides of the transversal, sorry, within parallel lines, opposite sides of the transversal. What we've got happening up here is that they're within the parallel lines, but they're on the same side of the transversal. They're not equal to each other. They add up to 180 degrees. They're called co-interior angles. So almost done. We've just got two more angle properties to talk about, and they are not to do with parallel lines. So this one is called the vertical angle theorem, and all that is if you've got a situation where you've got two lines crossed, the angles opposite each other are equal. Okay, they're called vertical angles. So the red ones would be equal. The blue ones would also be equal. So obviously they're not vertical, they're horizontal. But we call it the vertical angle theorem. It's basically angles opposite from each other when you've got two lines crossed over are equal. So the absolute final one is about angles in a triangle. I've squished into this corner up here, but angles in a triangle sum to 180. So if we add up all those angles in that triangle, they will equal 180 degrees, and that's the final one.